Our fifth speaker is Torben C. Rick, Curator of North American Archaeology at the National Museum of Natural History at the Smithsonian Institution. For millennia, marine ecosystems and organisms have played important roles in evolution and ecology. Oceans continue to be a crucial source of food and, as you heard early in the last talk, well-being for people around the world. However, overfishing, climate change, habitat destruction, and other threats have pushed many marine ecosystems to a crisis point. Combining studies on archaeology and historical ecology of North American coastal and island peoples, Dr. Rick explores 10,000 years of human interactions with marine ecosystems to elucidate long-term relationships between people and the sea. When integrated with modern environmental and biological perspectives, Dr. Rick's multidisciplinary research provides a framework for transcending contemporary environmental challenges and planning for a sustainable future. Representing Class 5's section on anthropology, Dr. Rick's talk title is Archaeology and the Future of Our Ocean Planet. Dr. Rick.
All right, well, good afternoon, everyone. I have a very long list of people to thank. I'm still kind of awestruck to even be up here today. I'm really honored in particular to represent Class 5 and my Section 51, Anthropology. Now I'm going to switch gears a little bit, and we're going to talk about archaeology. You probably surmised that from my title and the introduction. But specifically, I want to talk about the ways in which archaeology, the science of the human past, can actually help us better understand all of the environmental challenges that we're facing today. But before we do that, I want to take us back to the early to mid 1980s and talk a little bit about why I first got interested in science and archaeology, and ultimately how I came to see the study of the human past as a critical tool for helping us understand how we arrived at the present, how we arrived at this moment in time, what are all of the steps that led us here, and ultimately, as a key component of helping us decide where it is as a society that we hope to go in the future. All right, so in 1985, roughly, I was a fifth grader at Loma Vista Elementary School in Ventura, California, and we had a chance to take an amazing trip. We got to take an overnight field trip out to Catalina Island, and to the Catalina Island Marine Institute at Toyon Bay here on the bottom left. This would become, of course, the first of many, many trips that I took out to the Channel Islands, first with my parents and sister, later with my wife and daughters, and of course with colleagues and students over the years and decades. I remember aspects of this trip, though, like they were yesterday. You know, the cool, foggy mornings and warm, sunny afternoons, that crazy, life-filled smell of the ocean, scuba diving, or rather snorkeling, not scuba diving yet, but snorkeling in the kelp forests and seeing fish like this California Garibaldi. But one thing that just was straight up weird was this herd of bison. There was a herd of bison roaming around on Catalina Island. Now, to my fifth grade mind, that was just incredibly weird. You know, we had just learned about all the native mammals on Catalina Island, and there aren't very many to begin with. And the biggest one we were told was the island fox, which is about the size of a house cat. So what were these bison doing there? Right? Well, it turns out they were introduced in 1924, presumably for a film shoot, though that film never got made, we think. It's an odd story, right? It was years later, when I was an undergraduate at the University of California, Santa Barbara, and later as a graduate student at the University of Oregon, when I wanted to be a marine biologist, but I stumbled into an archaeology class, and it changed my life. You know, archaeology actually taught me what it was that those bison symbolized. They symbolized the truly profound impact that people have on the environments and ecosystems in which we live and spend time. And archaeology unlocked this world where we could reconstruct cross-culturally and all over the planet the ways in which people manipulate, interact with in both positive and negative ways the places that they live. And we could do this for centuries, millennia, or even longer time scales. And it taught me to see the world. Archaeology taught me to see the world in just a fundamentally different way. And so an example of that is I look at pictures like this. This is a beautiful spot on the California coast. It looks pristine or natural. There's not a person in sight, not a house, nothing around. But when I see this picture, what I see is this. Each one of those red lines and the numbers above them represents just a few of the literally dozens of archaeological sites that are in just this picture alone. Just the ones I've highlighted represent some 7,000 years of indigenous people settling on this spot, all the way up until about 200 years ago when Spanish missionaries came in and colonized the area. And so archaeology showed me that we could reconstruct human environmental interactions on long time scales, but it also taught me that it was a way of unlocking people's histories. There was literally a history sitting right beneath my feet that I knew very little about. And so archaeology was also a way to get past some of the sad atrocities of colonialism and start to move away from the attempts of erasing indigenous people's histories and bring those histories to life. At the same time, though, I was being exposed to all of the terrible things that we're confronted with on a daily basis. I took a lot of environmental studies courses at UC Santa Barbara, and each day we're talking about climate change, pollution, overharvest, habitat alteration, you name it. The depressing list goes on and on and on. And the question for me and so many of my colleagues became, how do we merge these two things? How do we merge the archaeological record and the unique things it can tell us about people and their environmental interactions through time? How do we merge that with all of these challenges that we're facing? And for us, it became this very simple but overarching question. What can the past tell us about the future of Earth's ecosystems on land and at sea? And from this, you can think we can reword it in a whole bunch of different ways. We can ask all sorts of sub-questions. We can develop all kinds of hypotheses to test with archaeological and other information. But at a very basic level, it was about piecing together the past to understand the present and to get us towards a better future. And our primary way that we do this, and the way that we reconstruct past coastal and other ecosystems, is, in coastal areas anyways, is looking at sites like these, shell middens. Shell middens, like that big pile on the left there, that's an intact shell midden, are the refuse or things that people left behind. They're often at a campsite or a village, and they're full of all the things that people were gathering and collecting and hunting around the local area. So in this case, it's full of shellfish and fish bone and marine mammal bones and plant remains. All of those things tell us a lot about what people were doing in an area, right? What they were eating, how they were foraging, but it also tells us about the local environment. And when we piece together a lot of different shell middens, this particular one's about 1,500 years old. When we piece together a lot of these sites from different time periods and different locations, we get these incredible diachronic perspectives of long-term human environmental interactions, in this case with the marine environment. And then we can layer on top of that historical information, historical records, historical museum collections, and of course perspectives from rich modern biological data going back the last few decades. This work is inherently interdisciplinary or transdisciplinary. We draw on geology, biology, ecology, archaeology, anthropology, history, the list goes on and on. But it's also one that involves literally dozens of collaborators and students. I'm honored to be here as an individual, but I am only here because I've had great mentors, great colleagues, great students to work with. And so much of what we do is a team effort. It's a collaboration of trying to bring the past to life. And also, perhaps some of the most important part of what we do is collaborating with Indigenous descendant communities today, working in consultation, collaboration, and partnership on everything from the questions we address to the interpretations that we make. All right, I want to shift gears a little bit for the rest of the talk and focus on a few examples of the work that we've done. And so this, in some ways, is a tale of two coasts. Our work is global in scope and scale, but we do a lot of it right here in North America. So we're going to start out on the East Coast, the Atlantic coast, and the Chesapeake Bay area. And then we're going to jump over to the West Coast and talk a little bit about work we've done in the Channel Islands. So who doesn't love an oyster, right? It's America's favorite sessile marine invertebrate, right? You gotta love them. Oysters, though, are amazing. They are a keystone species, they're iconic, they're an ecosystem engineer who makes habitat for other organisms, and they were a crucial source of food for people for thousands of years. We've also abused oysters, almost like we have in any other species. This diagram here is recently from the Washington Post. It's based on Maryland Department of Natural Resource data that looks at commercial harvest of oysters in just the Maryland waters of the Chesapeake Bay. The Virginia waters aren't much better, to be honest with you. And what this shows us is you start over here in the late 19th century, we were taking a massive amount of oysters out of the bay, but it crashed really quickly. It crashed really quickly and never recovered. And then, of course, we have disease comes in, and sort of the gauntlet is laid for oysters to be pushed into oblivion, right? There have been some signs of hope. The reason this story was in the Post is because there is a little blip right there to get excited about. Things are actually starting to look better. But when I see this, what I think of is, what in the heck was happening over here? All this space, we could go on the wall. This is just a tiny little blip. People were harvesting oysters for much longer than this. And so we set out to understand oyster harvest and the role of people in shaping the Chesapeake Bay over much longer timescales. And we did this by nesting together Pleistocene data from previous iterations of the Chesapeake Bay, partnering with my colleague Rowan Lockwood down at William & Mary to look at oysters from sites that were 35,000 years old or maybe even up to 120,000 or so years old. Then we pulled together data from dozens of archaeological sites that span the last 5,000 years of Native American harvest of oyster, and then we nested that all within the rich, modern conservation and biological studies of oysters. And we pulled together this really neat diachronic, long-term perspective on oysters. And it was a bit of a surprising result for us, because the overarching theme that came out of this work, and I should say that we measured over 100,000 oysters to look at size changes through time. We did age and other growth estimates on some of the oysters. We used stable isotopes to reconstruct salinity and nutrients. We compared them to other things that people were harvesting. We threw the gauntlet at these oysters. And what we came up with ultimately is that the indigenous fishery was sustainable on millennial timescales over thousands of years. This is despite people taking billions or perhaps even trillions of oysters out of the bay during that time period. And sure, there were localized signs of people influencing or promoting declines of oysters, but really the overarching trend was one towards sustainability and longevity. And we advanced a variety of reasons to help explain that, right? Was it lower population, different technologies? A big part of the puzzle was that people didn't seem to be harvesting much from deeper waters, so there were always population of oysters for recruitment. And ultimately, this led us to some concrete recommendations for how to manage the fishery today. And better yet, once we can restore those populations higher, how can we continue to eat oysters like we have for millennia? We took this study further and did a global comparison, brought together indigenous scholars, archaeologists, and others working on oysters up and down the Atlantic coast, out on the West Coast, in Australia. And the global study showed much the same thing, a pattern, an overarching pattern of sustainability. But it also showed us something that I think is even more important, and that's that if we're going to restore oysters or other organisms, we also should be restoring the connections between indigenous peoples and their traditional homelands. The two things, to me, are deeply intertwined, and we've shown that through some of our work on oysters. We've also done work like this on the West Coast, collaborating with a number of different scholars and looking at a wide variety of species. This map here shows Catalina that I mentioned at the beginning. We've also done a lot of work up here in the northern Channel Islands, or Channel Islands National Park. Here we've looked at a whole range of different species and their interactions with people. One of them is this endemic island fox that I mentioned at the beginning. These guys were pushed to the brink of extinction in the late 1990s. They've since recovered. It's a great conservation success story. But we did all sorts of archaeological, genomic, isotope research on foxes, and we showed that the original populations were likely introduced by Native Americans to the Channel Islands, or certainly were moved between islands by Tongva and Chumash people for thousands of years. They were also being provisioned by people in the deep past. And all of these, again, point to those connections that as we work to sustain populations of foxes, we need to think about their connections to people as well. We've looked at seal and sea lion population on the West Coast in the wake of the fur trade, right? Fur trade drove many of these animals to extinction. And then, of course, after the Marine Mammal Protection Act, they've rebounded to great levels where some are even crossing Pacific Coast Highway. We've shown that actually they've recovered in novel ways, unique, not like what they were for the previous 10,000 years. And again, this points to things we need to be thinking about in future climate scenarios and the pressures that different species might be placing on different ecosystems. We've also looked at fisheries like red abalones and shown great places to restore abalones based on 8,000 years of human harvest. These were also pushed to the brink of extinction or extirpation in areas, and so now we're showing good places for restoration and outplanting. All of this comes together with, I think, a couple or three kind of big ideas. The first of which is a lesson of hope, right? The archaeological record, for me at least, gives me hope. We are constantly bombarded by just awful news. Right? When it comes to the health of our planet, it is often just bad news. Sure, the archaeological record does show depletion and degradation and negative things, but it also shows us all of these sustainable approaches that people had in the past, right? And that, to me, is a lesson of hope for sustainability and resilience in the future. We also can get concrete conservation baselines. If we're looking to restore a particular ecosystem, archaeology can give us snapshots and perspectives from 100, 200, 500, 5,000 years ago that are critical for modeling into the future under different climate scenarios. And finally, there's this connection between environmental restoration and social justice, restoring the connections between people alongside restoring the ecosystems. The final point I want to leave everyone with, and to me, maybe I'm a simple person, I don't know, but to me, the simplest things sometimes are the most eloquent when we're doing science and research. And to me, it's this point, and particularly if we're thinking about the public and trying to engage people, and that's that people are part of nature. We've been part of nature for thousands of years, since the origin of our species. And to me, what that means is it comes with tremendous responsibility that we must be part of the sustainable ecosystems of the future. With that, thank you very much.
Before I thank you for introducing the next talk, which I think you have done in a very nice way, we do have some time for questions, please.
Yeah, thank you. I have a question about the midden that you showed at the very beginning, and you said this was an undisturbed midden, and I looked at it and said, well, it looked very disturbed to me in the sense that it had been, fairly recently exposed by erosion, and that's why you knew that it was there, and it was probably going to be destroyed in pretty short order by erosion. Are there ways of finding such things that are truly undisturbed, that are, say, 50 meters in from the shore, they're under a plateau and you see nothing on the surface or on the sides, any sensing methods or things like that, or do you just have to poke into the ground, or you talk to geologists about how to look for them in an intelligent way?
That is a great question. And yeah, I think of disturbance in a very loose way because everything in the archaeological record is disturbed in some way. But yeah, that particular site, we're looking at the eroding edge. But if we go just back a meter, there's intact material there that has not eroded at all. And that particular site even goes 10 meters inland. And then I think what you're getting to is there are lots of archaeological sites that are deeply buried. We don't even know they're there, so we have to do coring to try to figure out if there's a site there, or we dig fun things called shovel test pits. Everyone should do it at some point in their life where you dig a 50-meter hole round and try to see if there are deposits there. And then, yes, we can partner with geophysicists and do ground-penetrating radar, magnetometry, and all of those things then to define deposits that we can't see. And actually, that's a great way now of targeting areas where we might be most likely to find the best deposits. We tend to, with our community partnerships, oftentimes go into some of those disturbed exposures. We'll face off the outer edge. And the reason for that is that we're trying to leave the archaeological sites alone. We don't want to disturb them. And so we're trying to make lemonade, I started to say lemons out of lemonade out of lemons by, dealing with an exposure that will erode.
Okay, thank you.
Thank you for a terrific talk.
Thank you.